Hi there, today I'm going to present to you a tutorial on how to use Simplicity DiffExpress, a platform for differential expression analysis of RNA-seq data. So what we'll need is a count table like this one here, where each row has the count of a specific gene or transcript, and each column has a sample, and both the sample names and the transcript identifiers must be unique, but no specific pattern is required. We also need metadata table that will have a sample per row, and these names should match the names we have here on the count table. Here you should put any relevant information for your data. Well, now going to Simplicity platform. Here, once you do the login, you will be taken to this interface, and you can ask to start a new pipeline. Go to transcriptomics and then to differential expression analysis. So first, you're going to upload your RNA-seq count table. I'm going to open the count table, and after a few minutes, it will display the data for you. So as you can see here, I have a warning, and this is because it's not recognized the columns. So it's displaying this as a single item. That's because it's expecting to be comma separated. But if I say it is a tab separated file, it will automatically recognize all the information. Because this is a large table, it takes a few minutes. And here it is. You can see all the samples here and the genes here, and it's looking okay. Now we're gonna submit. Now we're gonna upload the metadata. So what it's saying here is that some characters were recognized. That was exactly in some of the names here, and it replaced to avoid any problems. One more time, I need to say that this is separated by tab. I need to check if everything is correct here. Everything seems okay. Now I can submit. And it's saying that this file is perfectly matched, means that it recognizes all the samples ID. Now I would like to add some fields for my analysis. So if you come here, this is the simple model. And what I'm doing here is to choose from the headings of my metadata file. I can go one by one like this, right? Say, for example, I want to add the batch and the cancer type. But to make it easier, I could ask to show all the fields. Of course, patient is not a variable of interest, so I will remove. Okay, so batch is not continuous exactly, and I want to remove this effect. For the cancer samples, healthy donor is my control, and gender is also an effect that I want to be removed from my analysis. I don't want to know what are the genes differently expressed between males and females, but I want that my model consider the variances between genders. So we'll click here. Same with age. I don't want to know what are the genes that are differently expressed due to age differences, but I want that the information of age is included in my analysis. And because age is numeric, as you can see here, I will say that this is continuous. Finally, I want to also analyze metastases, and I can come here and say that the baseline is no metastases. Okay. We have the step wizard down below here, and that will provide some quick information on how to set up each of the steps available. But if you need more details, you can always come to support. So now for the statistics, because this is a cancer data set, I would like to set the threshold of the log fold change to 2. And I'm happy with the other settings, so I will keep these 2. And I would like to show that these items specifically, if I turn it green, it would compare all the levels in a factor. So for example, here for cancer, we have 6 types of cancer plus the health donor. And if I activated that option in the statistics, it would compare the genes differently expressed between all the subtypes of cancer. But at the moment, I'm not interested in doing this. Here on the interaction, it is an opportunity to compare features, for example, metastases versus cancer. I already know that's gonna fail, and I will show you why. Just as an example. So let's say I want to do an interaction between metastasis and cancer. And that could be interesting because some cancers are prone to metastasis more than other. And I would like to see the combined effect of this. But you'll see that's gonna give me an error when I check the model. And that's because glioblastoma patients and healthy donors don't have metastases. So the model doesn't work. If I really want to study the interaction between cancer and metastases, I would have to come here and remove the samples, okay, like you can see here. But for the moment, I just want to remove the interaction and go with the simple analysis. So you can see everything is still here. I will check the model. And as you can see, the model has been successfully tested. So I can come here and can put the name of my project, example, and submit for analysis. Now I can go and check out my pipelines, can start a new differential expression analysis, or I can keep playing with this data. Let's keep playing with this data. So here no samples were removed. The history, as you can see, the first time we checked, we tried to do an interaction, it showed us there was a problem. And then we went back to this model and there was no issues. Now, let's go back to my interaction. So cancer versus metastases. So here I want to remove all the glioblastomas and the healthy donors. It tells me that 82 samples were removed. And now if you come here, it will tell you that 82 samples were removed, and it points you to the interaction of cancer and metastases. The only thing now, I need to set a new baseline for cancer. And I will just pick one. I will pick this one here. And also do the same here. But now I would like to compare the genes expression between all the categories. Let's check this model and see if it's working. Perfect. So I'll just come here and say example 2, submit for analysis. Now I would like to check out my pipelines. As you can see here, both examples are still running. It might take a while. But meanwhile, we can check this pipeline here. So this is the result interface. It tells us the pipeline number, the title you provided, and when it was submitted. Here it shows the statistical model that was created, and it's similar to the first example I did with you. Here it reminds all the settings of the statistical analysis tab. Here we have the log of the analysis. And so it's just describing all the steps that were done, and then in the end provides a summary of the genes found differently expressed. As you can see, there was no genes differently expressed due to metastases, but a lot of the genes, as expected, were differently expressed when compared to the healthy donors. Here we also have distribution plot, the BCV plot, the multi-dimensional scaling plot, where we can see how the data is distributed, and you will see that we have a batch effect, that samples from batch 5 and 6 are completely separated from the others, and that's why it's important to include the batch in our statistical model. So now we can go to the Output Explorer, where we have all the comparisons that were done, and also we can have a look on the heat maps. So this heat map can be downloaded later if you want to zoom in. And as you can see, we had done a cluster analysis. So here we have the samples, right? And the genes. This one I like because I take together all the genes differently expressed and plot them together. And these colorful lines here, they're showing the samples with metastases and different types of cancer. So this side here, we have mostly healthy donors. Anyway, if you download, you will be able to see in more detail. So for example, if I want to explore specifically the genes differently expressed between breast cancer patients and the healthy donors. I will click there and it will download files and display to you. So now we can see a table showing the log fold change between breast cancer and healthy donors, and also the p-value and the corrected p-value. We can sort this table by clicking in the error. And also we can see the heat maps for the genes differently expressed in this comparison here. And like the other heat maps, maybe you have a clustered option and the unclustered option. And you can also have a look in the MA plot where it shows the transcripts log CPM versus the log fold change in this comparison, and marks red the ones that are significantly differently expressed. So now clicking here, you go back to this main page and you can explore the other comparisons. Here on this tab, you can have a look on the citation recommendations. And here you can download all the files. It takes a while, but it will be downloaded direct to your computer. It is also possible to request further analysis and report an issue. Okay, thank you very much. I hope you enjoyed this tutorial.